Okay, 3.8, I'm talking about implicit differentiation. Now, I started to do this video, but then something went wrong. So here we go. I started this so far. And this is number one on the practice sheet. And it is an equation that has three terms in it. We have this term, we have this term, and this term. Now, some of them have x's, some of them have y's, some of them have just numbers. And here's the thing about implicit. If you're going to take the derivative of x, it's like normal. It's like all the derivatives we've done before, just the way you've been doing it. But if we take the derivative of y, then what we're going to do is we're going to put this little symbol at the end of the derivative, dy dx, or y prime if you like that better. I don't like y prime in this because it might look like y to the first if you're too sloppy. So this is very much something that will stick out when you see it. And there's a reason it needs to. So let's look at this one, okay? Number one, we have a product rule here going on. So you got an x and you got a y, and this 2 goes with the x. So when I take the derivative, I'm going to say derivative, not derivative, not derivative, derivative, right? That's how we were doing. So the derivative is 2. And because it's just x and y wasn't involved with that derivative, then, like normal. And then I write y. Now, I didn't take the derivative of y. I just brought it down. So there's no need to put this little tag at the end of this. So derivative, no derivative, comes out 2y. Plus, no derivative, 2x. Derivative of y would be 1, but with a dy dx tag on the end of it. So I don't have to write times 1, right? So that's why it looks like this. And all this comes from that, the product rule. Minus. This is power rule, good old-fashioned y squared becomes 2y, but because y was the variable, we need dy dx attached to it. Okay? So y squared becomes 2y dy dx. And then 1, the derivative is 0, so please don't forget that. That happens to me sometimes. I write the number again. Don't do that. Okay, so that's the derivative. That's doing implicit differentiation. Now, it's going to be like solving an equation, but for a certain variable. And that variable is dy dx. You want to get that guy all by himself on one side of the equation. Sound familiar? So we got 1, 2, 3 terms, and 2 of them have the dy dx in it. So those 2 should stay over here. This guy is in the wrong place. So I'm going to say minus 2y on both sides. And that'll get rid of him over here. Oops, minus 2y dy dx. And that's equal to negative 2y now, because 0 minus anything is this. Okay, so now I have 2 terms with 2y dx in it, and I want to get dy dx out by itself. So I'm going to factor it like it's the GCF. Right? There's the GCF. And then what I get when I divide each one of these terms by dy dx is 2x minus 2y. Like so. Okay, so I'm just pulling the dy dx out of each term, and I'm left with this. Now, anytime I have something times my variable, I want to get rid of this something, I need to divide both sides by that something. Yeah, it's bracket, parentheses, same thing. Right? So what that will do is it'll cancel it over there, and my dy dx, the derivative of y with respect to x, the thing I'm looking for, is going to be this. Now, all of them have a 2, so I can go ahead and divide a 2 out of all of them. So there's no more 2, 2, 2. But I'm still left with this. Okay. Now, here is the reason why I wanted to do this by short answer and not with multiple choice. I remember with multiple choice, they moved the minus sign out here and then changed the sign inside or switch them. And I could go into why that is, but I would rather you just show me your work, show me this answer, negative y over x minus y, and that's good, Okay. Number 2. Notice each one of these problems take a little bit of time. And that is unfortunate, but is the nature of the beast. All right? This one is x cubed plus 3x squared y plus y cubed equal to 8. Now, I don't care what that number is because I know when I do the derivative, it's going to go away. The derivative of x cubed by itself is just 3x squared like you normally do it. But no y, no dy dx. It's just like normal. This one is going to be product rule again, x and y. So derivative, 6x, no derivative, no dy dx, plus no derivative, 3x squared, and then derivative, which is dy dx. That's the derivative of y. Okay, so all of this goes with him. He goes with that. And that leaves y cubed, which becomes 3y squared. Again, dy dx, just like before. All that's equal to 0, because the derivative of 8 is 0. Okay. So of all 4 of these terms, 1, 2, 3, 4, 2 of them have dy dx. So these 2 are in the wrong place. I'm going to subtract them to this side. Cool. So boom, boom. Left with 3x squared dy dx plus 3y squared dy dx. And that's equal to negative 3x squared minus 6xy. Okay. Now, like before, we pull out the dy dx. I'll use a parentheses this time. You get 3x squared plus 3y squared left over, equal to this business over here. And then I divide that thing. I'm not going to write it again. 3x squared plus 3y squared just cancels. And we get our derivative. Dy dx is equal to... Now, all of them have a 3 in common, so I'm going to go ahead and divide a 3 out of all of them. They don't all have an x in common. They don't all have a y in common. So this ends up being negative x squared minus 2xy, 6 divided by 3, and then x squared plus y squared. No, you can't cancel those x squareds. Don't even think about it. No, 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 no. Remember, you have to factor before you can cancel anything. And those do, this factors with a GCF, and this doesn't factor at all, so nothing's going to cancel after you factor. So just leave it like this. Lovely. I love this answer. Okay. Those 2 are definitely types of problems you would see on the quiz. Wink, wink, nudge, nudge. This next one, x plus y over x minus y, and then equal to x squared plus y squared. So I changed it on the quiz to be not quite as nasty, but something that you can do in this case is, as it is, if you were to take the derivative, this would be quotient rule. The quotient rule means that you would say the bottom one's derivative times the top minus the top one's derivative times the bottom all over the bottom squared. And then you'd have these 2 derivatives, and then you'd have dy dx all over the place in fractions. And I don't like that. So what I'm going to do is I'm going to see this as x minus y in parentheses. And I'm going to do something that before I start taking the derivative, I'm going to multiply both sides by that thing. Right? So that'll cancel it over here. Just leave me with x plus y. And that'll give me a product of 2 binomials, which I can FOIL. X times x squared is x cubed. X squared times y is x squared y. Don't forget that minus sign. Y squared times x is positive xy squared. Not quite the same, so I can't cancel them, in case you were thinking about doing that. Okay. Now, yes, you have more terms, and 2 of them are product rule, but you don't have to deal with fractions anymore, which, yay, right? Okay. 1, 2 on the left side, and then 1, 2, 3, 4 on the right side, 2 of them being product rule. Derivative of x is 1. The derivative of y is dy dx, right? Boom, done with the left side. The derivative of x cubed is 3x squared. Nice. Nothing to put on there. This is like normal. This one, product rule, so we're going to involve the negative with the x squared, and the derivative is negative 2x, and then not derivative, plus not derivative, so negative x squared, and then derivative dy dx. Yeah? Cool. All that belongs to him. Over here, I've got derivative, which is 1 y squared. I didn't write the 1, but you can. And then plus not derivative, and then derivative 2y dy dx. All of that belongs belongs to him. And then one last one, minus 3y squared is the derivative, dy dx. Again, because y is involved, I need dy dx. Okay, so yeah, this is a bit more involved as far as the number of things you're taking the derivative of, but believe me, better than the fraction thing, quotient rule. Okay, now I got to figure out of all these terms where the dy dx terms are. They're all on the right side except for him. So I'm going to subtract him over here somewhere. And then, see, he belongs, he don't belong, so we're going to get rid of him. He's going to come over here, minus y squared. He belongs, he doesn't, so I'm going to change his sign, plus 2xy, plus 2xy. And minus 3x squared, minus 3x squared. Okay, so all of this ends up giving me 1 minus y squared plus 2xy minus, was it 3x squared? Sorry, I can't read my own writing. That's all that stuff on the left. That's gone, that's gone. And then we're left with negative x squared dy dx. That's gone. Plus, I'm going to rearrange this, 2xy dy dx. I just like the way that looks better. Minus 3y squared dy dx. Minus dy dx. Okay. 4 terms and 4 terms, huh? We started off with 2 terms and 4 terms, and then that became 2, 4, 5, 6 terms on the right, 2 terms, and that was a total of 8. Okay. Sometimes you just got to count the number of terms, make sure you didn't forget anything. Now, the dy dx comes out. Dy dx, negative x squared plus 2xy minus 3y squared minus 1. Don't forget that guy. He's actually in front, so he needs to be there when you pull him out. And then 1 minus y squared plus 2xy minus 3x squared. And then we divide that big old thing, which I don't want to rewrite underneath it because it's just going to cancel anyway. And then this is going to be negative x squared plus 2xy minus 3y squared minus 1. My neighbors are upset about something. I don't know. Anyway, so there we go. And yeah, could anything cancel? No! Stop trying it. It doesn't factor. Remember, factor before you cancel. If you can't factor it, nothing cancels. Okay. X to the 4th equal to the cotangent of y. Yeah, this one is got a trig function in it. But, you know, we know our trig derivative, so it should be fine, right? Right? Okay, derivative of x to the 4th, 4x to the 3rd. No problems, just like normal. The derivative of cotangent is negative cosecant squared of y times dy dx. Yes, because you have a y, you need dy dx. Good. Okay, yeah. And so the only term that's got dy dx is over here, and there's nothing added or subtracted to it, so there's no need to like combine it by pulling it out like we've been doing. So the only thing we have to do is divide by negative cosecant squared of y, the thing in front, and they cancel. Negative cosecant squared of y. Now you can leave it like this, that'd be okay. But if you remember, 1 over cosecant is actually sine. So it'd be really classy if you change this to negative 4x cubed and brought this up as sine squared of y. Ooh, very lovely. But if you want to leave it like this, that's okay too. I just like this one better. It's just, ooh, nice. It's so nice. Okay. This is probably foolhardy trying to do number 5 in this small space, but hey, I am a fool. All right, I'm not putting parentheses around this angle too, because inside derivative, outside, oh, chain rule. Yes, you are correct. It is a chain rule problem. And then plus x to the 4th equal to y to the 4th. Okay, these don't seem like they're going to be too much trouble. But this one, chain rule. Outside derivative is negative sine, parentheses, times the inside derivative, which is product rule. So derivative is 1 times y plus, not derivative, x times the derivative of y is dy dx. So 1 times y plus x times dy. And then we're going to throw xy back in here. Okay? And then derivative of x to the fourth is 4x to the third equal. The derivative of y to the fourth is 4y to the third, but don't forget you have a dy dx there. Oh, now, here's the thing about this problem. This dy dx is inside of a parentheses. Now, you can get it out of that parentheses if you distribute this sign into both of these. Not a big deal, honestly. Watch. You distribute this whole thing into him and him. It looks like this. I'm going to throw the y in front. Yeah, these two look like this. And then minus x, throwing the x in front, sine of xy, in parentheses, dy dx. So no longer in the parentheses. He's out and about, can combine with other guys. Oh, don't forget you got plus, 4x to the cubed on that side. On the other side, we have just one term, and that's 4y cubed dy dx. Hey, that makes me feel like taking this term and moving it over here by doing the opposite of what you see. Change the sign. Plus, blah, blah, blah. So, okay, so that will cancel, and what you're left with is, yeah, no, I didn't leave myself nearly enough room, but that's okay. You guys can follow, right? Negative y sine of xy is right here. He's gone. He's on the other side now. Plus 4x cubed is already there, equals. This guy, which was already there, 4y cubed dy dx, plus x sine of xy dy dx. Oh, God, it barely fits. Okay. Almost got in there. All right, and then we pull out the dy dx like it's the GCF. We're left with 4y cubed plus x sine of xy. And over here, I'm going to rearrange this because I like having a positive thing first. You don't have to. Okay, and then I divide by the thing. It's going to cancel. Divide by, here it's 4y cubed plus x sine of xy. And yes, it looks so similar, but it's not enough for you to cancel anything. So don't try it. It's good the way it is. It's lovely. Okay. Woo! Those are the number 3, 4, and 5 are the hard ones on this page, okay? So if you didn't like them, I'm sorry. I know it can feel overwhelming to have so much work to do in a problem. But if you think about it as pieces of smaller problems put together, those smaller problems aren't so bad. It's all, what's the derivative of this? What's the product rule? What's the chain rule? You know, things that you should know at this point. Or at least passively know. 6 and 7 are actually way nicer. So it starts off looking kind of ugly, like they do. Y to the fifth plus x cubed equal y squared plus 9x. And they want to know, what is the slope? And they give you a 0.01. You remember what slope is? It's right, it's derivative. Very good. That was very nice. I'm just assuming you said derivative when I asked. You probably didn't. You're probably just sitting there munching on snacks. You might not even be watching at this point. Who knows? Looking at your phone, texting your friends. Quarantine life, baby. All right, moving on. So we're going to do the derivative, is essentially what I'm saying. But you don't have to do all that rearranging and getting dy dx by itself. That's what's good about this. So each one of these terms has its own derivative, and there's no product rule, no chain rule. Oh, this is so nice. 5y to the fourth is the derivative. Don't forget your dy dx, all right? X to the third becomes 3x squared, just like normal. Y squared becomes 2y, but with a dy dx tagged onto it. And then 9x becomes 9, just like normal. Separate those two. Okay, so like before, we would have to get these two on the same side, this guy over here, and then factor out the dy dx, and then divide by that thing, and then we'd be done. A lot of work. It's usually the same process, and once you do it a lot, you'll get used to it. But in this case, we can start to replace all of the letters, all of these, with either numbers or m for slope. So 5 is a number. Y is 1, right? This is x and this is y. to the fourth. And then dy dx, which is the derivative, is slope. So we're going to call it m. Cool. 3 times 0 squared. Ooh, he going to be gone. 2 times 1 times m plus 9. That's what I get when I replace all my letters and my dy dx's with numbers and m. So 1 to the fourth is 1. 1 times 5 is 5. So we get 5m. And then that's 0. And then that's 2m. And that's plus 9. And look at this equation. Look how nice he is. Oh, solve for m, man. Subtract 2m on both sides. Like algebra all over again. Divide by 3. And the slope is 3. And that is what they wanted. Yeah. So like I said, 6 and 7, not quite as bad. You're still doing the implicit differentiation, but after that, it becomes like a normal equation. All right, this one, x cubed y cubed equal to 8 is your guy, and they want you to find the slope at 2, 1. So yeah, it's a product rule, but hey, we're good at product rules now, aren't we? Okay. Derivative, 3x squared, and then not derivative, y cubed. No dy dx, because we did not take the derivative. Plus, not derivative, x cubed, derivative, 3y squared, dy dx, because we are taking the derivative of y in this one. And that's equal to, not 8, 0. Ah. All right, so we can start plugging in numbers. We got 3, we got 2 squared, we got 1 to the third, we got 2 to the third, we got 3, we got 1 squared, we got m, that's equal to 0. So 2 squared is 4, 4 times 3 is 12. 2 to the third is 8. 8 times 3 is 24. M equal to 0. Okay, so we just subtract 12 at this point. 24m equal to negative 12. Divide by 24, and it doesn't go in evenly, so we got to make it a fraction. Negative 1/2. Right, 12 goes in both. Okay, so implicit differentiation is just like regular derivatives, only if there's a y involved, we have this dy dx tag onto it. And if we're asked for slope, then all we got to do is plug in numbers instead of getting dy dx by itself. Which, yay. Number 8 is another one of those, but it's got trig in it, of course, and it's the last one. So we got 4x squared y minus pi cosine of y, and that's equal to 5 pi. And the point they give us is 1 comma pi. So first, before we get into this, we have to come to an understanding that if you see pi, you have to realize it's a number. It's like just like a regular number. If you would rather call it 3 and deal with it that way, you can. Just remember that the 3 needs to come back to pi. You know what? Don't do that. Just keep it pi. And remember it's a number, okay? I'm glad we had that talk. Okay. This is product rule. Hopefully you recognized it. And we're going to do the derivative and then not the derivative plus not the derivative times the derivative, which is dy dx. All right? And then over here, this is not product rule because pi is a number, remember? And a number in front of a trig function doesn't mean product rule. It just means bring it down. It's a coefficient. But the derivative of cosine is negative sine of y. And because y is involved, dy dx. Now what's the derivative of 5 pi? It's not 5. Oh, that's right. It's 0. And it's 0 because 5 pi is a number. And the derivative of any number, no matter what it is 0. Okie dokie. Now let's plug in some numbers. We got 8 times 1 times pi. We got 4 times 1 squared times m. Sorry, I'm singing. These two negatives become positive. We got pi, and we got the sine of pi times m. So let's put sine of pi around it, parentheses around it. Okay, so the two negatives became positive. There's pi, there's sine of y, but instead of y, it's pi. Am I rapping at this point? What's going on? All right, so this is 8 pi. And this is for m. And this sine of pi, you have to remember, is 0. Sine of pi is 0. Sine of 180 degrees is 0. So all of this is 0. So it just goes away. Cool, huh? 4m, m's the only one that is the variable that I'm looking for. So let's subtract 8 pi over here. We get 4m equal to negative 8 pi. And then we divide by 4, and our m is negative 2 pi. There's our slope. Yeah, it's a negative 2 pi, but hey, whatever. If I were to write the equation of the tangent line, I would have to go through this whole like y minus pi equal to negative 2 pi times x minus 1 thing, but I don't have to do that because they didn't ask it. They just asked for slope. So hey, here you go, and we're done. Okay. All right, well, hope you do much better on the 3.8 quiz now.